Hey guys, we're going to talk about graphing log functions today. So last week we graphed exponential functions, which would be like this one. But today we're going to graph log functions, which is like this one. And here is the first thing you need to know with graphing logs. To graph a log function, you first need to know what its inverse is. So in this problem, f of x, and notice we have that little -1. Hopefully y'all remember doing inverse functions where you have that little -1 sign or -1 thing there. And excuse me, for some reason this thing keeps jumping back and forth from small to big. So here we have the exponential function and its inverse. And so today I'm not going to ask you to actually find the inverse, but there will come a time where I will give you this function and you need to figure out what its inverse is. So we'll have to review kind of how to find the inverse. We have done that in the past, but again, don't worry about that today. I just want you to be able to graph. I'll actually give you both the function and its inverse. So here's what's the interesting thing about inverse functions. If you were to graph them, they are just a reflection over this line. So let me actually change colors here. When you graph inverse functions, they are just a reflection over this line here. And you may remember, maybe not, when you have inverses, if I have a table of a function, its inverse, you're just going to switch the x and y values. And that's really what we're going to do. We're going to first find some x and y values for this one, and then we're just going to switch the x and y values to get the graph of the log function. Again, today I just want you to kind of get the idea of graphing the log function and then switching the x and y values. And then tomorrow we'll kind of go a little bit deeper. So what I'm going to do is I'm going to figure out some points here. So if I plug in -1 into this function, 2 to the -1st power is 0.5. And again, you can either use your calculator or write it out. But where this came from is I did 2 to the -1st power. So I'm just plugging in -1 into the x here and then simplifying. All right, if I plug in 0, 2 to the 0 is 1. And if I plug in 1, 2 to the 1st is 2. So I'm going to graph this here. So -1, 0.5 is here. 0, 1 is here. And 1, 2 is here. Now, before we continue, we got to do something. When we graph, let me erase this, exponentials, you will remember that we have this thing called a horizontal asymptote. And so I'm going to graph the horizontal asymptote here. What color should I use? We'll use red. And actually, I'll use pink. So because there's nothing here, so there's, come on. So because there's nothing here, sorry, it's just taking a minute. This is being silly. Because there's nothing here, no +2 or whatever, that means my horizontal asymptote is at 0. So I'm just gonna, there's my horizontal asymptote. And again, the reason that is because here you would say there's +0 there. Okay, there's nothing there. Okay, so then the graph of this function would look like this. So notice these are the points I graphed. It would look something like this. And it would do that. So that's the graph of this one. Okay, that's just a review of what we did last week, graphing exponential. So if I want to graph this one over here, and I'm going to use, I'll use blue to actually graph it. All I'm going to do, oops, I think my computer is dying here. Let me plug it in. There we go. Okay, so lost my train of thought. So what I'm going to do is I'm just going to switch these x and y values. So this is 0.5, -1. This is 1, 0. And this is 2, 1. So you're just switching the x and y values. So this was negative 1.5. This is 0.5, negative 1. This is 0, 1. That's 1, 0. And again, the reason I'm doing that is because these are inverses. And that's why it's going to be important understanding this. Because graphing logs is really difficult if you don't already have the graph of its inverse. Now, it's possible to do it, but it just becomes a little bit tedious. So now here's what's interesting. We had a horizontal asymptote here at 0. So I want to again point that out. You had a horizontal asymptote at 0. In a log function, you don't have a horizontal asymptote, you have a vertical asymptote. And the vertical asymptote is just going to be the opposite of the horizontal asymptote here. So you had a horizontal asymptote at 0, you're going to have a vertical asymptote on the log at 0. Oops. Again, let me change the thickness here. So you're going to have a vertical asymptote at 0. And you'll see why that's important when we actually graph these points. So I'm going to graph these points. So negative 5, 0.5, negative 1, which is right here. 1, 0, which is right here. And 2, 1, which is right here. And so what it'll do is it'll get close to this line and then just kind of do like that. And what you'll notice is that this red line that I've drawn, which was the graph of this exponential, is just a reflection of this blue line, which was the graph of the log. And so I do want to do another one, but this video is already about 7 minutes. So the one thing I want you to take away is graph the exponential. And you should already know how to do that. If you don't, please make sure you get some help. With the log, you're just switching the x and y values and making a vertical asymptote rather than a horizontal one. And the vertical is going to be at the same place as the horizontal one is there. So again, I'm going to go ahead and close this video. Please let me know if you have any questions.